So good evening, students. Today we are going to see, let me discuss one problem on the supernode analysis. So first of all, I write the question. So let me discuss one problem. So the question is, we are going to determine the current in the 5 ohm resistor. Current in the 5 ohm resistor for the circuit or network given below. So this is the question. So I will draw the circuit diagram. So it contains a 10 ampere current source. Then we are having a 3 ohm resistor. Then it's connected with 2 ohm resistor. Then we are having a 1 ohm resistor. Then we are having a voltage source connected between the two nodes. So the voltage magnitude is 20 volt. So it's connected with 5 ohm resistor along with the voltage source. So the voltage source magnitude is 10 volt. So next, finally, we are having a branch connected with this, having a 2 ohm resistor. So this is the given circuit. So, so in this problem, so we are going to determine the current in the 5 ohm resistor. So applying the node analysis, first we have to assume the node voltages. So totally in this circuit we are having totally 4 nodes. So out of that 4 nodes, we are having 3 nodes as the main nodes. So it is named as 1, 2, and 3. The fourth node is considered to be the datum node or reference node. So it is already known to you. So this potential is maintained as 0 volt. So we are going to consider only the main nodes. We are going to assume the node voltages. So we are going to assume node voltages as V1, V2, and V3. So we are going to assume the node voltages here V1, here in this node V2, for this node we are having V3. So what is our requirement? We have to calculate the current in the 5 ohm resistor. So current flowing in this 5 ohm resistor, we are having the expression potential difference divided by the resistance. So current flowing in the 5 ohm resistor required is potential difference V3 minus 10 by 5. So this is the expression. So from this expression, we have to calculate V3. On calculating V3, we can able to get the current. So first we are going to form 3 equations. Solving that equation, we are going to find out V3. From that, we are going to calculate the current. So in this problem, so there is no difficulty in applying the Kirchhoff's current law for node 1 because we are having a voltage source between 2 and 3. So it is slightly difficult while we are applying the nodal analysis directly for the nodes 2 and 3. So we are having problem only for 2 and 3. So there is no problem in applying the nodal analysis for node 1. So applying the Kirchhoff's current law for node 1, so there is no difficulty. Okay. So we are going to apply first. So we are going to apply Kirchhoff's current law for node 1. So we are going to assume all the currents as a leaving current. So we are not changing the default direction of the current source. So default direction of this current source is entering current towards the node. Rest of the currents we are assuming as a leaving current. So what is Kirchhoff's current law? So sum of incoming currents are equal to the outgoing current. So here we are having an incoming current as 10 ampere. Incoming current is 10 ampere. Outgoing currents are, so these two are the outgoing currents. So first I am writing the outgoing currents. V1 by 3 plus V1 minus V2 by 2 is equal to 10. So simplification, we are getting 1 by 3 plus 1 by 2 into V1 minus 1 by 2 into V2 is equal to 10. So if you are simplifying this equation, so on the simplification, we are getting 0.83 into V1 minus 0.5 into V2 is equal to 10. So this is the first equation. So there is no problem in writing the equation for node 1. So we have written that equation. So we named that equation as 1. So next we are going to apply the Kirchhoff's current law for node 2. So here we are having that problem because we are having a voltage source between 2 and 3. So we could not write the current flowing in this branch because we are having a voltage source. So as well as the voltage source is not having any internal resistance, so source transformation is also not possible here. So we are forming the super node. So here the super node is formed between 2 and 3. So referring the circuit, super node is formed between super node is formed between nodes 2 and 3. So we are going to ignore the branch where the voltage source is present. We are going to write the equation combinedly. So we are going to ignore this branch where the voltage source is present. We are going to write the equation directly. So writing the equation directly, we are going to assume all the currents as a leaving current. So here you can see. So we are going to assume, so I'm using a different color for this. So this is the leaving current. This is one leaving current. We are ignoring this branch. So this branch is ignored. Okay. So this is the leaving current. This is another one leaving current. Okay. So writing the equation combinedly for node 2 and 3, we can write the equation as follows. So we can write the equation V2 so we can write the equation V2 minus V1 by 2 plus all the currents are leaving currents. V2 by 1. We are ignoring the branch where the voltage source is present. We are writing for the rest of the branches. V3 minus 10 by 5 plus V3 by 2 is equal to 0. So now we are rearranging this equation. Minus 1 by 2 into V1. We are taking the coefficients of V2. 1 by 2 plus 1. 1 by 2 plus 1. These are the coefficients of V2. So coefficient of V3 we are getting 1 by 5 plus 1 by 2 into V3 is equal to 10 by 5. So we are simplifying this equation. We are getting minus 0.5 into V1 plus 1.5 into V2. Here 0.7 into V3 is equal to 2. So this is the second equation. So we are ignoring the branch where the voltage source is present. We have written the equation combinedly for 2 and 3 for the rest of the branches which are related to 2 and 3. Now we are going to consider the ignored branch. So in the ignored branch is containing the voltage source of magnitude 20 volt. We are going to write the voltage equation directly for this branch. So that is V2 minus V3 by 20, V2 minus V3 is equal to 20. So we are writing the equation directly. V2 minus V3 is equal to 20. So that is the third equation. Now, solving these three equations, we can able to get V1, V2 and V3. So we have to calculate only V3. So by solving equations 1, 2 and 3, 1, 2 and 3, so we are getting V3 as minus 8.42 volt. So this is the voltage we are getting. So what is the current we required? Current flowing in the 5 ohm resistor. So the expression is V3 minus 10 divided by 5. So V3 is minus 8.42. Here it is minus 10 by 5. So dividing, we are getting minus 3.68 ampere as a current. So actually the current flow direction what we have selected is the leaving current, but actually the current is flowing towards the node. So only we are getting this minus sign. So our assumed direction of current is opposite to the original direction of the current. So finally the current flowing in the 5 ohm resistor, we are getting the answer as 3.68 ampere. Okay. So I will quickly summarize this problem again. So in the problem, they have asked to determine the current in the 5 ohm resistor. So here the super node is formed between the nodes 2 and 3 where the voltage source is connected. So directly we are applying the Kirchhoff's current law for node 1. We are writing that equation. We are having a problem in writing the equation for the nodes 2 and 3. So we are ignoring the branch where the voltage source is present. We are writing the equation combinedly for the nodes 2 and 3. Finally, we are considering the ignored branch. We are writing the third equation. So our requirement to get the current flowing the 5 ohm resistor V3 minus 10 by 5. But what is the direction of current we have assumed is the current flowing, it is the outgoing flow of current. But what is the answer we are getting is minus 3.68. So what is it shows that our assumed direction of current is opposite to the original direction of current. So original direction of current is towards the node. So that is the meaning we are getting finally. So magnitude remains the same, but what is the direction of current we have assumed will be opposite. So that is the meaning for this minus sign. So I hope you have understood this. So thank you.